Majestic Major, a model aircraft project. This is part 7. Fitting a Spektrum DM8 2.4 GHz module to a Futaba 9-zap transmitter, then fitting the fuel tank to the airframe and painting the front part. I already had one Futaba 9-zap transmitter, but recently I bought another one from my friend Charlie Warren. Charlie trades as flyingwidgetsupplies.com. I'll put the address on screen. These days Charlie is concentrating on second-hand equipment rather than new, and sells a lot via eBay. I find his stuff always priced right and always good quality. When I went to see him last week, I was amazed at how much stock he actually carries. You may be thinking, why do I need two Futaba 9-zap transmitters? And the reason for that is I use a different mode. I use throttle right for aircraft, and I use throttle left for sailing my laser yacht. So now I have a transmitter set to mode 1 and a transmitter set to mode 2, because it's difficult, if not impossible, to change the modes on a Futaba 9-zap. Please feel free to correct me if I'm wrong about this. And also I wanted to fit a Spektrum 2.4 GHz module into one of the transmitters. The module just plugs into the back of the transmitter, but the aerial required you to remove the original aerial and fit a long plastic thing. And I always found it very difficult, if not impossible, to remove the aerial from a 9-zap without dismantling it. I gave it some thought, and as you can see from what's been on screen, I just used a piece of silicone rubber tubing around the existing aerial and then pressed the 2.4 GHz aerial's mounting onto that. If only everything in life was so simple. I've had this module for a few years and never thought about doing this. All I need to do now to return the transmitter to its original state is remove the 2.4 GHz aerial, pull up the main aerial and install a standard module in the back. This particular aerial is damaged. I've ordered a new one and it should be on its way. I'm only going to use this transmitter with the left-hand throttle for sailing boats. A few years ago I built some steamboats and then I started building them for customers commercially, which from a profitability point of view really wasn't viable, as building the type of steam launch featured in my series called How to Build a Model Steam Launch takes a long time. Once I was sailing one of my steam launches on a local lake, used by the club that I was a member of at the time. I used to use a PCM 1024 system on my original throttle right 9-zap radio. I took the frequency peg from the pegboard and clipped it onto my transmitter, then I raised steam and put the boat in the water. The only thing I noticed was the whistle was intermittent. But other than that, the boat ran perfectly. Then one of the club members started jumping up and down and saying, "Oh, my boat's gone out of control," etc., etc. This shows how good the PCM 1024 system is. We were both on the same frequency. My boat worked, his didn't. And that's why I have this module that plugs into the back to convert it to 2.4 GHz, to avoid the hassle of changing crystals in the transmitter module and the receiver. The transmitter that I bought from my friend Charlie Warren has sustained some damage, which was very relative to the price that I paid for it. It only has a broken switch, I've got one on order, and the job is simplicity itself, as both of the corner pieces just slide out of the casing once you've dismantled it. Since I first started in radio control, I've always used Futaba systems, and I've never had any problems. I do have a Spektrum DX7, and that's quite good too. I must say though that I'm very impressed with the quality of the electronics and construction of a Futaba 9-zap. I mean, just look at it, it's a piece of art. I removed the broken switch and I've temporarily placed the corner piece back in position so I don't lose anything. Now it's time to work on the airframe. I need to do a couple of things. One of them is cap off all these holes at the front. If I don't do that, oil from the engine will get into the inside of the airframe. Temporarily I'm refitting the engine mount, and as you can see it fits really nice now. And as per usual, I'm making a cardboard template. Before I got it right though, I did make 3. But cardboard is very cheap and very easy to work. Once I got the right shape, I just drew round it onto a piece of mahogany like this. Then I took the piece of mahogany over to the bandsaw and cut it out, and in this clip I'm shaping the part that fits around the tank outlet. I've also modified the engine mount by drilling a hole near the back of it and then using my bandsaw to turn the hole into a U shape as shown here. I set up my video camera to record this sequence, but unfortunately I forgot to press the record button. taking incompetence to a new level, and I mean incompetence, not incontinence. There is a subtle difference. I changed the aluminium tubing that was supplied with the tank for some pieces of 4mm copper piping. I've found from experience in the past that the aluminium tubing supplied with these tanks fractures very easily. My original plan was to have the two feeds to the tank sticking out of the front like this. But then I changed my mind and fitted some longer pieces of silicone rubber tubing which stick out of the bottom of the airplane. You can't see it in this clip, but right at the bottom of the front part is a large drain hole. I mentioned that the aluminium tubing was brittle, and look at this. I can snap it very easily just with my hands, and it's only a small piece. This tank, of course, is Chinese made under the name of World Models. I've used them in the past and they seem to be okay, provided that you fit them with copper piping. Here's a finished layout, and the tank is loosely fitted in position. Inside the tank, these two outer pipes go all the way to the top, and the centre pipe is connected via a piece of silicone rubber tubing inside the tank to a weight called a clunk. This weight has a hole down the centre and picks up the fuel. So if you fly the model upside down, the clunk still picks up the fuel because it's always at the lowest point. All I have to do now is connect a short piece of silicone rubber piping to the piece of copper pipe that sticks up and connect that in turn to the carburetor on the engine. I'll show you what I mean. Here's the engine sat in its approximate position, and from the side you can see the short pipe that goes from the clunk pipe's outlet to the needle valve for mixture control, which is fitted to the carburetor. A fuel filter is a good idea, but generally I tend to fit fuel filters to the outlet of the fuel from the fuel bottle. This is a tin of Ronseal outdoor polyurethane varnish, and it's not the water-based stuff. I'm using this to paint the piece of mahogany that I'm going to stick in the front. And while on the subject of paint, this is Humbrol paint, and I've bought it because I think it should be a good colour match for the model. This Humbrol paint is gloss finish, and I want sort of a semi-matte finish. So once this blue paint has dried thoroughly, nice and shiny, I'll just apply some satin varnish over the top. I've done this before and it definitely works. The main thing is, it's the same colour as the solar text covering, and it should look okay in the end. The varnish has dried on the piece of mahogany, so now I'm going to stick it in place using some cyanoacrylate adhesive or superglue. Not only will this piece of mahogany cover up the messy holes in the firewall, it will give the model more of a vintage appearance. To make sure I got the piece of mahogany in the correct position, I thought it would be a good idea to refit the engine mount temporarily. And yes, it fits perfectly. And that concludes this episode. Stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.